Our story begins many moons ago, in fact, in ancient times. And it's easy to blame the Greeks for this problem because, well, I don't know, they wrote a lot of stuff down and we keep reading it. But I want you to think about any ancient person, right? They're sitting here on the earth and they look up into the sky and they see, when they take these time-elapse photographs, everybody who took a time-elapse photograph, 2,000-3,000 years ago could look at the North Star right here. Okay, everybody in the northern hemisphere, fine. And they would notice that all of the stars were apparently circling around Polaris. And you can look up time-elapse photograph of the stars and you'll see things that look like this. And the ones that are further out are moving more, and it seems like the entire sky is rotating. So who can blame them for thinking that the Earth is here, all right, let's set it down like that, and the sky is here, and all of the stars are on a big sheet of plastic that's spinning around us? Because when you wake up in the morning, you think that you are still, don't you? I think that I'm still when I wake up in the morning. It's quiet, nothing's moving. Okay, so everything was going fine for thousands of years until this crazy guy named Aristarchus. So that might have been the first problem. Who names their little son Aristarchus of Samos? Anyway, he had a little bit too much wine one day and he said, hey guys, what if instead of all of this stuff going like this, wait for it, this, what if we're just going like this? And everybody dismissed him as, well, that guy in the town who had a little bit too much wine. And who could blame them? Because we had specific problems with that apparently really stupid idea. Two guys came up, oh, this guy said Earth spins, and he said that Earth moves around the sun. And everybody said, ha, that's stupid. Okay, so time went on. And this was about 300 BC when that stuff was said. About 200 BC, so you can imagine there were stories told of this crazy old drinking guy named Aristarchus who had these crazy ideas. But there was a wonderful fellow named Hipparchus. Hipparchus! Like that us at the end? Yeah, yeah, awesome. Hipparchus came around in 200 BC, and he said that's stupid for the following reasons. And then Ptolemy also in 200 AD, another 400 years later. So 500 years, can you imagine 500 years ago, somebody saying something stupid and you still talking about it? But here it is. It's like the worst story ever. Ptolemy, that famous Greek astronomer. These two guys teamed up across 400 years and presented two arguments against Aristarchus, who had been dead for a very long time. But they said, Aristarchus, you're stupid because, one, you can't feel, what they mean is, I can't feel rotation of the Earth. And when I'm on a merry-go-round at Six Flags, I can feel that it's rotating, right? The other problem is you can't see. Now, here's the thing. If we were moving around the sun, then we would have slightly different perspectives on the stars. Wait a second. Yep, that's right. We would be moving around the sun like that, and we'd have slightly different perspectives on the stars throughout the year. And you can't see those. You can't see parallax in stars, and I'll have a video on parallax pretty soon because parallax is really a tricky concept. It was tricky for me to first understand. Anyway, they came up with these two arguments, and Aristarchus, who was dead, said nothing, but everybody else said, yeah, I thought that guy was wrong. So this is a Greek fight. And you know who's gonna win in a Greek fight, right? The Greeks, except in this case, they lost because these two arguments from Hipparchus and Ptolemy are wrong. You can't feel the rotation. I mean, okay, you can't, but you can if you have sensitive equipment. It's very small. It's like, I don't know, something like 1 or 2 or less than 1% of your weight is actually affected by the rotation of the Earth depending on where you are on the Earth. And, oh, you can't see parallax in stars? Well, you can if you have powerful telescopes, but they only had their own eyes. So we need telescopes and electronic measurement to refute those guys. Now notice, we didn't get electronic measurement until well after the 1600s, but telescopes, hey, 1600s. So everything went well, a lot of people lived and a lot of people died, and there were good times and there were bad times. There were a lot of bad times, but there were a lot of good times also until the 1600s. And in the 1600s there was this fellow named Giordano Bruno. You want to guess if he was Greek or not? I don't think he was, that's my hint. Giordano Bruno says, well, he thought a lot of crazy things about the universe. He was pretty much nutso. This was a bad time to be nutso because he was ultimately killed by the Inquisition. Nobody expects the Spanish Inquisition, but one of the crazy things that he said about the universe for no reason, by the way, there's not really any reason for him thinking this, like, he didn't do any special experiments or anything, but he thought that the Earth moved. By the way, no reason. Weird. So it's not really science, but it is unfortunate that he was killed for these ideas. Shoot. All right, he said that Earth moves around the sun. Have you ever heard that idea before? Well, let's see. I guess it was about 1900 years earlier that a drinking Greek suggested the same thing, but he was shot down. And likewise, Giordano was, well, burned alive. Earth moves around sun. And he also thought the Earth rotated, and he thought some other crazy things. Look him up if you want to know crazy. That was the, oh well, that was actually in 1600 that he burned to death. So, then we're gonna get Galileo, and you know about Galileo. Galileo be all like, what's a good color? Teal. Teal is a good Galileo color. Galileo Galilei said that, well, he was actually charged with the same heresy. He also thought that. But he was a little bit more careful. Like, he would say things like, but I still think everything that you guys are saying is true. So nobody killed him for his beliefs, but he was in jail for quite a bit of time. And the other interesting thing about Galileo is, while he said, what did he say? He also thought that, well, here's the sun fixed, and here's the Earth going around that direction, and also spinning around itself. And he said, hey, this explains all the astronomical data much better. The problem was his arguments were very esoteric and astronomical. So they were completely out of reach of the common person of that time. They were totally, like, uneducated people, the masses, these guys over here were all like, what? What'd you say about the precession of Venus? What'd you say about occlusion? What? Zenith? What? And they didn't know any of the words even. Heck! He was working in, what, Latin? Probably. All right, so let's move on. Maybe he wrote in Italian. I don't know. He was Italian. Then there was this guy who was French. And we're going to have to fast forward here to the 1850s, because eventually scientific society began to accept Galileo's ideas. I mean, they were pretty convincing. He was very smart, and he wrote them all up. But there was a Frenchman, and just so there's no mistake, he was entirely French. His mother named him Jean Bernard Léon, keep going, accent aigu, okay, Foucault. Jean-Bernard Léon Foucault was a very gifted experimentalist after he dropped out of med school. See, he was initially thinking that he'd be a doctor, but he was afraid of blood. How about that? That's a lot like my story, and I wonder how many physicists would have been an okay doctor if they weren't afraid of blood. All right, so Jean-Bernard Léon Foucault became actually the 19th century Banksy. So if you can imagine him, he would go over to large buildings in France. They had a lot of these. And he, let's say here's a building, right? And the building's like, meh. And the building sometimes had really big domes like that. And in the middle of the night, he would come in and he would build a pendulum that hung from the dome. Here he is building a pendulum, and the pendulum, well, he set it up like this. He put an enormous pendulum bob at the end and very little mass of the string and just an enormous lead covered with brass, big old pendulum bob dangling right there. And then he made a very thin thread, and the thin thread went right here. And then he would go home. And then Jean-Bernard Léon Foucault would come back and say to everyone in this large building the next day, "Whoa, how'd all that get there? Hey, I know about this system. Let me tell you something cool." And he took fire because he had also mastered fire. And he mastered fire and burned this thread with his Bic lighter or candle or something. And when it burned, he said, "Hey everybody, come over here and watch." And everybody was standing over here and watching. The common man, right? The other people who happened to be in, well, where was he? In the Pantheon, for instance, in Paris. And, oh, because he was French, right? And all these guys said, "What's gonna happen?" And one of them was standing right here, and he got knocked over because he didn't know much about pendulums. But he fell over, and he was rushed away to the hospital, because as I said, this is a really massive ball. But this thing goes, whee, and it goes back and forth. And that's all well and good because people had been looking at pendulums. I mean, Galileo himself had been looking at pendulums while he was in church. The lights were swinging and he was timing the period of the pendulum with his heartbeat. And that's awesome. He discovered some cool things about pendulums. But Jean-Bernard Léon Foucault noticed that the plane of the pendulum would not be constant on Earth. So Jean-Bernard Léon Foucault said that the plane of the pendulum would rotate. And he proved this to crowds starting in 1850, what was it, 1851 or 2 or something. It was probably 1851. And he said, "Hey guys, look at this. This proves that the Earth rotates." And everybody was like, "Oh," collectively. They all said, "Oh." Like, all of them, though, said, "Oh," but they said it in a very French way. They said, "Oh," or something like that. And in 1851, he said, "Listen, I can explain it to you like this." Where's the pendulum? Sorry, I'll be right back. I don't know where my pendulum is. Okay, great, I've got my globe. So the pendulum then on the North Pole, this is a pendulum, a Foucault pendulum at the North Pole. Ah! That would be a problem. So the pendulum's at the North Pole, and people at the North Pole are saying to themselves, "Gosh, it's really cold up here." And also, well, the pendulum doesn't appear to move at all. See, you were wrong, Foucault. But lo and behold, the Earth is in fact actually spinning in real life. And so, oh, it goes the other way, sorry. It's spinning that direction, and they see that the pendulum is moving, so they conclude that the Earth itself is moving. And Jean-Bernard Léon Foucault comes back and he says, "Voilà, regardez ce que j'ai fait." And all the French people say, "Oui, oui. Oh, I understand now. Thank you. Très bien. Au revoir." Jean-Bernard Léon Foucault came in and he said, "Oh, there is one more thing that I forgot to tell you, and that is that in Paris, the oscillation went from here to, bear with me here, to here, that's half a rotation, right? To here in more than a day. In fact, the rate of precession of the, oh, I guess it was going this way because the Earth is going this direction underneath it. So the rate of precession of the pendulum was 270 degrees per day. And if you want to know why it wasn't, for instance, 360 degrees per day, then you'll have to watch the next video. Sorry. Have been the first problem. Who names their little son Aristarchus of Samos? Anyway, he had a little bit too much wine one day and he said, "Hey guys, what if instead of all of this stuff going like this," wait, found us. Because when you wake up in the morning, you think that you are still, don't you? I think that I'm still when I wake up in the morning. It's quiet. Nothing's moving. Okay, so everything was going fine for thousands of years until this crazy guy named Aristarchus. So that my sky, and they see when they take these time-elapse photographs Everybody who took a time-lapse photograph, 2,000-3,000 years ago could look at the North Star right here. Okay, everybody in the northern hemisphere, fine. And they would notice that all of the stars were apparently circling around Polaris. And you can look up time-lapse photograph of the stars and you'll see things that look like this. And the ones that are further out are moving more, and it seems like the entire sky is rotating. So who can blame them for thinking that the Earth is here, all right, let's set it down like that, and the sky is here, and all of the stars are on a big sheet of plastic that's spinning around? Our story begins many moons ago, in fact, in ancient times. And it's easy to blame the Greeks for this problem because, well, I don't know, they wrote a lot of stuff down and we keep reading it. But I want you to think about any ancient person, right? They're sitting here on the earth and they look up into